arrangements. So the general arrangements, how it is divided, you can see very deeply. Here you see the thing is, so the overall structure of EV, so any EV, the classification, independent of the classification, for any EV if we go, the major components, major parts can be divided into three subsections. One is, see here, one is the electric propulsion subsystems. That is the driving part. So this major part is the driving part. That part is even available in case of IC engines also. There is that electric here propulsion system here run by the electric. In case of electric vehicle, the propulsion systems run by the IC engine in case of IC. So this is the essential part. Next, the additional part, if you are coming the next part, this one is energy source subsystems. This is the here only battery plays a major role here. Then third one is the auxiliary subsystems. This auxiliary subsystems, why for means is the small battery systems. So this auxiliary subsystems will power the power supply for the auxiliary devices like audio, video systems we are using. No, so other control systems, other things. This is the small battery. So how we are dividing into three subsections. One is electric propulsion. Another one is major battery systems, that is the energy source system, subsystems. Another one is auxiliary subsystem, the small battery sections. So if we are in the electric vehicle, we have the two mode of operation, right? One is braking mode, another one is oscillatory mode. So here, the based on the control inputs from the oscillator or braking pedal, the vehicle controller provides proper control signal to the power electronics converters. So here, in power electronic converters, power flow can be controlled. Whether power flow has to flow from during oscillating mode. During oscillating mode, whether power flow has to be moved from electric vehicle, electric motor to the mechanical systems, or during during braking mode, that is a regenerating mode, whether mechanical transmission feeding back to the motor. So that is decided here. Then next we come to that. This part is very clear, right? This is the bidirectional part. See, this is that the mechanical link, electrical link, control link. If you are seeing the link variations here, so we can clearly understand this. Then in part of that battery system here, energy source. Here energy source is nothing but the battery. So the battery BMS, the battery management systems we are given, that also can be directly controlled with that vehicle controller. So why we are giving the bidirectional means, so how much battery is available, whether battery is low or high, how much charge is available, what is the SOC level, that can feed to the battery back. So here one more, this block, if you are seeing that energy refilling unit, this is the hybrid vehicle, what we are shown here, what we are discussing here. So that is the energy filling also is possible here. That is the genset unit is available here. This is the part of the energy source. Next, we'll come to the auxiliary subsystem. This is this is available in all the independent of that electric vehicle. It is available in all the cars, all the transportations. That is the small battery. We can say 12-volt battery. So that battery is available to supply the auxiliary power devices like audio, video systems and other weather conditions, all those things. So this is the conceptual illustration of the general EV configurations. So when we go to the classification of electric vehicles, so broadly the electric vehicle can be divided into four types, major classification here. One is fully battery electric vehicles. Another one is plug-in hybrid electric vehicles. The third one is hybrid electric vehicles. The recent upcoming electric vehicle is fuel cell electric vehicles. So when it come to the battery electric vehicles, only the vehicle is operated by the battery, completely battery. Here there is no fully electric vehicle. Here there is no IC engines. The battery is fully operated by the vehicle is fully operated by the battery. Next we have to the plug-in. Here is the combination of both. So we have the battery as well as the IC engines. So here main source is battery. Then so when the charge is going depleted, when the charge is going down, the vehicle propulsion support by the IC engines. So it offers more flexibility than the battery alone vehicle. Then hybrid electric vehicle. Here there is no external charging point for the charging the batteries. Here the battery will get charged by the IC engine itself during the degenerative braking. the motor will act as the generator. So through that, power is generated. The power is going to charge the battery. That will happen in that hybrid electric vehicle. Then fuel cell along with the IC engines. So IC engine is main here. In hybrid electric vehicle, IC engine is the main fuel, main propulsion systems that is supported by the battery. Next, fuel cell electric vehicle, if you come to that, here fuel is hydrogen. So hydrogen fuel cells will generate the electricity to propel the motor. So that is the futurist EVs. This is the major classification. So if we come to the battery electric vehicle, see here. So battery is the rechargeable battery. So this is the nowadays we are using it, right? So nowadays that generally what we are using in major things, major commercial, our general purpose application is this is the electric vehicle, battery electric vehicle only. Here only the vehicle is powered by the onboard rechargeable batteries. Here there is no IC engine, fully electric vehicle. This is fully electric vehicle. So we know the futures very well. This is the zero emission. Here depends only, the thing is here drawback is only depends upon the electric propulsion depends upon the only batteries. So this is the examples. Tesla and some Chevrolet, Nissan's companies, they are giving these batteries. Even many companies have come now come in the market. Then advantages, well known about the advantages is quieter operations. We can, if you go by the electric vehicle, we can feel that. Then lower maintenance is very low. The bill is very low. It's environmental friendly because there are no IC engines here involved here. So it's the fully environmental friendly. So here only challenges in this battery electric vehicle is here compared to IC engines, limited range. So that can be this threats can be avoided by improving the infrastructure, charging infrastructures availability. Okay, na? This is that battery. Next, we'll come to the hybrid electric vehicle. Here, combination of IC engines and battery. So both will assist the engine to move. Here, the main hybrid electric vehicle is the main thing is IC engine. So main fuel is the vehicle is run by the main vehicle run by the IC engines only. It is supported by the electric vehicle, that battery. Okay, now. So here, then how the battery is getting recharged here? The battery is recharged by the self-charging through the regenerative braking through the IC engines. So through the propulsion mode, the motor will act as a motor only. During regenerative braking mode, the motor will act as a generator. Through that, battery will get charged. So these are some examples of hybrid electric vehicle. Toyota and Honda, they are releasing this type of electric vehicle. Maybe new companies also might have come. Then advantages is a better fuel efficiency than the normal conventional IC engines. Here, no need of external charging because through regenerative braking, battery is getting automatically recharged. So here, no extra charging bills here. So, but even though the challenge is here, still that IC depends upon the IC engines. So we can expect some of the carbon emissions here. Next, we go to the plug-in hybrid. So, difference between hybrid and plug-in is here we have the battery charger. Here, battery charger unit, we have separate unit here to get the battery charged. So, here that plug-in hybrid electric vehicle, the main propulsion based on the batteries. So, battery is supported by the IC engine. IC engine, that is the fuel tank, petrol, diesel, or gasoline. Here, whenever suppose this can be little extend, if you are over the little round range extended, this vehicle can be used. Here, the battery, suppose this main field depends upon the battery only. Suppose battery is getting down, that the battery charge is less than 20%. We know that battery is a good maintaining charge batteries 20 to S4 level is 20 to 80%, right? So if it is less than 20%, better will change the fuel from battery to IC engines. So this is the advantage of plug-in hybrid electric vehicles. So greater flexibility. The main advantages is here greater flexibility with the reduced fuel and emissions is available, but less emissions comparatively pure IC engines. Then fuel cell is the futuric electric vehicle. We can say this is the fuel cell. Fuel depends upon the fuel cell. So the very main advantage of the fuel cell is we are getting the water only is the outlet. So we can without any threads, without any this one we can use these fuel cells. But fuel cell infrastructures and other generations, there's a recent research is going on. Still, this is not a developed. So here, the once it's come, then we can very compactly we can use. But for customer, we have to educate that how to use all the things that is though some things, some drawbacks which is available. Even this is the futuristic electric vehicle. This is the fuel cell. So fuel cell is happening is chemical energy is converting into the electrical energy that is driving the electric motors. So here, this is the some futuristic electric vehicles. The cost is high. So obviously, when we go for the luxuries and more convenience we're expecting, so proportionally we have to pay the more, right? No, so that is the here the difference is here. One more challenge is cost. One more challenge is limited hydrogen refilling infrastructures. Then purely depends upon the hydrogen production here. So clean hydrogen productions. So recent many researches is going on in the fuel cell generation production, hydrogen production. Then one more thing we can say like this is the extension of electric vehicle. So we have pure first type we have seen the battery type, right? So this is the extension of the electric vehicle. So we have the IC engine for the backup. Here we have the IC engine based backup. Here this you see this block we have the IC engines here extension of this. So ISC is nothing but the integrator starter generator. That is the generator only. So that will that the engine coupled with the generator. So engine will start the generators. Then this and all we can use it for the some truck, some kind of purpose we can be used. But nowadays this is they're telling this process is discontinued. So we'll see how the future comes to wait and see. So this is the thing. Then if you go for the hybrid electric vehicles in more deeper, so we can, if you come to the working point of view, so here we can classify the based on the, so this based on the, previously we have seen based on the configurations, how the component structure that we have seen. Now we come to the mode of operation. So in come to the mode of operation, the hybrid electric vehicle we can divide into majorly three types. One is series hybrid vehicle, parallel hybrid vehicle, and series parallel hybrid vehicle. So in case of series hybrid vehicle, if you are seeing that mode is the mode of operation is unique. One is series. So the other here, if you are seeing this, this is the layout of the series hybrid electric vehicle. If you are seeing this layout of electric vehicle, here the mode is unique. So here the vehicle propulsion can be either driven by IC engine or battery. So this is the thing, either by either engine or battery. So here IC genset is there, powertrain. So powertrain, we know that powertrain is that power electron is controllers. So here this is the train by the AC engines, which is generator. So it will, if you are fuel IC engine, we are fueling through that, the motor is connected, that will charge the battery. So that will drive the motor. This is the motor part. So motor will drive the engines. Or either by engine or by the battery. This is the series mode. Right now. So here in parallel, if you go the parallel mode, these also three mode of operations possible. One is either by the IC engine or by the battery or by the combination of both. Combination of engine and battery. In case of series mode, so either IC engine mode or battery mode only applicable. But when come to the parallel hybrid electric vehicle, here either IC engine or battery or combination of both. So this type of parallel hybrid electric vehicle is nowadays is more becoming more popular. So if you are seeing that this type of hybrid parallel electric vehicle, we are seeing that truck, heavy truck vehicles and all, this mode is operated now. Then we'll come to that series parallel mode. Here, when we are coming the series parallel mode, here, so there are two modes of operations possible here. So one is a series path, another one is parallel path. So in series path mode, the series path leads to the generator, the join with this ESS, the generator join with this ESS. So that will drive the motors. So in this path, the mechanical power of the engine is converted into the electrical power through the generator. Then the electrical power potentially flow to the battery ESS or to the entire through the driving mechanism. That means it will charge the simultaneously the operation will happen. So it will charge the battery as well as drive the vehicles. So in second path, parallel path. In the parallel path, the engine is connected to the gear set. See this engine. The engine is connected to the conventional drive time. So in this path, the mechanical power of the engine is partially or entirely transferred to the mechanical drive. So not to the wheels. So this entire mechanical power of the engine cannot meet the vehicle's power demand. Then the the motor will supply the additional power to the wheels. So here is that this is the series parallel communication. So here that both the things, the combination of serial parallel communication is preferable when we are it is both the mode is we can change the mode, series mode as well as parallel mode. Both the mode is possible here. The series hybrid behavior is preferable when we'll go in the city driving. So we can change the mode of operations. So the mode of operation can be controlled easily. So the when you are going in the city driving conditions, we can change into the series hybrid mode preferable. When we go for the highway, the parallel hybrid vehicle is disabled. When we go for the some upstairs downs, if it is if you are going, if the engine needs the vehicle needs more torque means then we can make both series and parallel combination. This here the main advantages is simultaneously battery also can charge it here. So that is the thing. So then this is the mode of operation series parallel combination. Any doubts here? Shall I proceed?
Yes, ma'am.
Yeah, thank you. Here, when come to that comparison, if you're general, then just to make it clear, I have given this table. So here, battery vehicle, a plug-in hybrid vehicle. So primary power source for the battery mode is only battery. Here, plug-in hybrid electric vehicle, PHEV, plug-in means the main thing is battery. Then it is supported by the fuel, IC engine. In hybrid electric vehicle, the main fuel is fuel that is supported by the battery. Okay, no? So that's why it's come first. It's second. That fuel in case of hybrid electric vehicle, the major part is supported by the IC engine, supported with the battery. So if you come to the emissions point of view, here zero emission because fully electric. Here, since fuel IC engine supported by the battery, here low major power is battery. That's why it's low emissions. But here major part of hybrid electric vehicle, major part is IC engine. That's why the emission is moderate. It is little higher than the plug-in hybrid electric vehicle. Then range, if you are driving range, if you are seeing that it's a limited range only we can drive this vehicle. This is the extended range. Then hybrid electric vehicle we go for the long range because the main driven depends upon the IC engines. Then charging methodology, if you are seeing the charging in terms of charging methodology, this is only completely plug-in in case of battery vehicle. Then plug-in vehicle, if you are seeing plug-in plus fuel, here in hybrid electric vehicle, there is no plug-in charging point is won't be available. Here the batteries will charge it by the regenerating. I think the things is clear, right? Okay. So here then if you come to the point, so then here classification of hybrid electric vehicle, if you are coming here, again we are dividing in terms of the voltage and power range. So hybrid electric vehicle we are dividing, here you see micro hybrid electric vehicles, mild hybrid electric vehicles, fully hybrid electric vehicles, and plug-in hybrid. These are the major four classification. So this is nothing but hybrid electric vehicles only. So the dividing based on the ratings. So ratings, if you're seeing that voltage rating in micro vehicles, they're seeing 12 volt and 48 volt. 12 volt for the auxiliary power device, 40 volt for the major battery. So power range, we can drive this vehicle up to 5 kilowatts. So fuel economy, this vehicle is very optimal for the city drivings like autos, like mini autos, the electrical vehicle autos we are seeing, no? So that will come under this category. So regenerative braking is possible here, but it is not that much extent. It is less. Here battery type we are using for this micro hybrid electric vehicles is this lead acid batteries and gel batteries. This cost is low. Then here thing is here, as I told, the regenerative braking is complete regenerative braking. Recovering is not possible here. So little bit only we can regenerate the battery. Then we'll go for the mild hybrid electric vehicles. The voltage range is 48 volt and 200 volt. 48 volt for the auxiliary power device, 200 volt for the main battery. The power range we can extend up to 20 kilowatts. The fuels we can little more, we can save the fuel savings up to 20%. So recovery is somewhat better compared to the micro range here. Then here battery type we are using is nickel metal hydride batteries and lithium ion batteries. Then here advantages we have a little more freedom to optimize the more flexibility, and driving comfort will get it because of the high voltage range. Then here the does not have the exclusively electric propulsion systems in this mild hybrid electric vehicle. Then if you go the full electric vehicle, we know the voltage range is full hybrid, so above 150. So full regeneration is here. Full regenerative braking is possible. We can recover more regenerative braking here because of the high voltage. Then we say more than 40 kilowatts is power range. So fuel economy about see around 50%, 40% is possible. The battery type we are expecting that nickel metal hydroxide lithium ion batteries. Then advantages is here zero emissions because mainly here it depends upon the full hybrid electric vehicle. That's why this types of electric vehicle, full hybrid electric vehicle, where the very suitable is the driving the some vehicles will where we cannot go, man can enter and take the automatic things. There we can drive this full automatic electric vehicle with the tunnels and indoor activities. Then here the vehicle does not have exclusive electric propulsion because it's hybrid. Okay, and that is the only drawback. Then this electric vehicle we have seen the range is 400 to 800 volts, as Sir also discussed in the first session. That around 600 volt he explained the structure of this. Then power we can go up to 80 kilowatts. The batteries mainly nowadays all the cars is made of a battery made of lithium ion batteries, right? So the mile range, if you are going that kilometer range, if you are seeing that mileage is 80 to 150. Nowadays above 500 so that could be achieved in the future. Here the thing is the threads is because of the high voltage and more power rating, the increase in vehicle mass and volumes. So that is the only thing. The without past recharging other infrastructures, this won't be not that much feasible. So plug-in, we discussed the long range. Why we are going for plug-in hybrid? To get the long range of vehicles. This is the AC outlet. We can plug in, so we can use it. We can wherever we get the charging point, we can charge it to the grid point, right? The power is 80 to 150 kilowatts. So it can drove in the range of 60 miles. Now more, I think 120 also, 150 also, around 150 also the vehicles have come. Then fully regenerative braking is fully is possible. The batteries, we know that as in the electric vehicles, lithium ion batteries. So these are the major classifications. So complete classifications over. So if you have any doubts, you can ask. Otherwise, I go with the next title, that is the current trends. So current trends, if you are, I think you are clear in that major classification. These are the major classification of EV vehicles. When we go to the current trends, so the current trends is focusing to get the battery, to improve the battery technology and efficiency, as well as to expand the charging infrastructures, as well as how we are integrating because of the electric vehicle we are using, the power demand is getting increasing. So how to demand this increasing power? So how to integrate how to integrate this with the renewable energy sources? By the way, we can reduce the cost and the carbon footprints. These are the major current areas, this research and all the advanced technologies moving towards. Then, according to here, overall global wise, if you are seeing that EV adoptions is expecting to increase, reaching by 70 millions by 2025, and it may go 30% more by that end of this decade 2030. That is expected. The EV is more popularity. We know that because there is the cleaner and the more efficient energy, right? So current trends in the Indian EV market, if you see that, So increasing adoptions, we can discuss in that 3 point of view current trends. So adoptions is getting increasing. So because of rapid increase in adoptions and government also taking some initiatives. Then we know that fuel range, that petrol and diesel also getting day by day, that fuel range also getting increasing that amount. Then consumer awareness also, now that people are thinking, now if you are going to buy, next we are deciding to go for the car, means people are now started thinking whether to go with the pure IC engines or hybrid mode or pure electric mode. That much awareness is catered among the people also. Then alternate way, people are thinking about that environmental benefits also, because nowadays we are seeing that we are facing so many that environmental effect, correct? No, so because the awareness also I think is increased now. Then government also, in case of government also supporting. So government is giving some subsidies, tax benefits, some incentives. So those things also is nowadays government also taking some initiative to make the environment of EV growth. Then challenges is actually, we all of us, we know that the major things before buying the EV vehicles, how as a customer we are thinking that then where will get the charging infrastructures, correct? No, that range, because we are go for the long driving, then we have to look for the where is the this one charging, next charging stations available. So that the range anxiety is there. Then one more thing, major thing is the high initial purchase cost. So these are the addressing challenging areas of the EV. So this one we discussed already. So this is the rise in EV adoptions. So countries like developed countries like US and China, Europe and all, they are majority 30% of the vehicles already, the 30%, 30 to 40%, 30% of the vehicles now is come with the EVs only. So still more 20% they are making the developments in the TV, modern technologies, other charging infrastructures. We are very, in India, by developing countries like India, we are lagging in charging infrastructures. So that is the thing, but we can, in future, we can see more things, more developed things. Then second one, we have discussed that battery technology is going on. So now the recent trends and innovations, the lithium-ion batteries, all the vehicles we are using that nowadays. The batteries is lithium-ion batteries only is using because of its advantages. But in future, more development, research and developments happening in that solid state batteries also. So the main in future, the lithium-ion batteries can be replaced by the solid state batteries because of the more power density and less leakage. So in case of solid state lithium-ion batteries, we are using the liquid as the electrodes. In case of solid state batteries, solid electrodes we can be used. So solid electrodes like here, solid electrodes can like here some oxides, solid ionic conductors, electron insulating materials, lithium superanic conductors, sodium superanic conductors, lithium nitrates. So these are the electrolytes. There is still development research is going on in the solid state battery that we can expect in futures. Then these are the things. So lithium-ion batteries are the currently more popular in all the EVs because of these high densities and lifelong cycles and relatively low cost. But if you go for the solid state battery, obviously because of the high density and more safety, cost will be little more than this lithium-ion batteries. But in case of safety concerns, it will be more safety than the lithium-ion batteries. So these are the research going on. In still more research like lithium sulfur, lithium air. So that can be new batteries can continuously the future researchers are exploring that new combination of electrolytes and elements to get the more benefit. It may be the future it is EV. They can be used. So in charging infrastructures, obviously we have to increase the charging infrastructures availability. So it should be available for the private and public charging networks. Then charging time also matters here. So charging, we have to wait for more charging to get the 100%. So that is the major challenges here. Then accessibility. So wherever we are move around, whether it's a company, factories, or in that highways, that accessibility should be is very one of the thing. It should be it should be regardless of the location. So the charging accessibility is needed in residential areas, workplaces, public spaces. Then future development, wireless charging, future development is going on with wireless charging. So we are seeing nowadays more, as academician, I can say the more research papers I am seeing in that wireless charging and smart grid integration. These are the recent research is going on. So that may improve that charging infrastructures. Then, if you're overall, if you are seeing this, the future, that current trends, we can divide into four major categories: zero emissions and enhancing infrastructures, improvements, enhancement, and smart charging and intelligent biotic. The one more main advantages of this EV we are going, people are liking is the V2X technology. So V2X technology means V2X means X to any devices. The V2 means the communications, correct? No, vehicle to any communications. V for vehicle, vehicle to X for any communications, any device. It can be personal device, mobiles or cars, or with the grid, or with the smart buildings. So that is the V2X technology. Recently, more developments is going on. So we can also from that we can even we can also V2 through the V2X technology we can connect through cars. Correct? No, that meetings can arrange. We can see by connecting that smart technologies, smart communications. From the car only we can monitor that whether the office, what is this going on, other things we can monitor those things. Then V2G, G2V technology also. So how we are integration with the renewable sources. This is the important thing. This is the main advantages of the EV vehicles we are using. Then other things I think I discussed more. Charging station also is somewhat automatic building, utility, that B2G, G2 technology, that off-peak hour charging. So people will, if you are, so government is that encouragements, if you are charging with off-peak hours instead of peak hours. So those things will come under the smart charging technologies. Then in point of customer trends, if you consider customer parameters, so customer trends, if we are discussing that points here, price range and social and psychological acceptance, still we are lagging in this. Charging stations, because price range we know it little high comparatively. IC engines, wavy vehicles little high. Then social and psychological acceptance, still people are fear about this, because we in the newspapers we are seeing like some battery accident. Just we are parked and went during that summer areas that batteries got fire. So still some acceptance, social psychological acceptance, still we are in this area we have to improve. Then charging stations availability.
Hello, madam. Hello, 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 hello.
Sir, ma'am is left, I think so, sir.
Yeah, wait. I think net issue. Please, just 2 minutes. Wait. I think disconnect.
Sorry, I will not
Okay,
avoid
okay,
the meeting.
okay. Hello.
Yes, sir. It's audible, right?
Now it is okay, mom. You take care.
Okay. Okay, yeah, sure. So visible, sir?
Yeah, not mom. Now it is okay, mom. Visible, mom.
Okay. So that we come to the conclusion like recent at most end we have come recent developments. So if you that recent developments and research and things is going on in terms of optimal charging to obtain the optimal charging techniques, plannings.
Madam, just minute, mom. Okay,
Yes.
now okay. Now it is okay.
Okay, sir.
Okay, mom. The screen is not fully visible. That's only. Okay, mom. Now it is
Now it's
okay.
okay. Ah, yes, yes.
Okay, okay. Proceed, mom. Proceed, mom.
Yes, sure. So then minimizing challenges as we are looking towards the optimal charging scheduling techniques and planning about that EV infrastructure is improving. Minimizing charging times we're expecting battery swapping stations and future advancements in EV technology. Then challenges as barriers, range anxiety, charging times and cost.
Hello, madam.
These
Madam,
are the
screen is not visible, mom.
screen
Hello.
is not visible. Now it's okay,
Yeah,
sir.
yeah. No, not madam. Not
I,
madam. Now
not
screen is
visible.
not visible, ma'am. Please share a screen, ma'am.
Wait a minute, sir. Wait a minute, sir. This. Now it's okay, sir.
Not madam. Not visible.
Is it? We come to the conclusion. Just a minute, sir. Give me
Ah,
some half minute.
okay, ma'am. Okay, take.
Simple, sir.
Now
Not.
okay.
Okay, sir.
Not full.
Okay, thank you. Sorry for the interrupt. So it is research gaps. So I am giving for current researchers, those who want to continue research in electric vehicles. I am giving some overall that some generalized research topics also. I wanted to share as a academician. So different types of EVs and the charging infrastructures. How we can improve types of EV, which are the types you are taking, so that types you have to see while taking the research topics in the electric vehicle, you have to first you check the which types of EV we are selecting. Then that also one thing you can select it based on their charging infrastructures, how to improve the infrastructures, how to increase the charging timings. Those things, those areas also you can go with that researches and various EV charging technologies and the methods to optimize the optimization of EV chargings and reduce the timings. The integration with this EV, integration with the EV, the smart metering and how to integrate with the non-renewables, renewable energy sources. So those things, the recent research things. Then, by the way, we can optimal placements of EV converters also, power grid, all those things. Is the futuric research gaps is available. Just you can go with it. Future research if you want to select these EV vehicles. There's so many things is available as academician. So many papers also is now upcoming. So you can go through the paper. Even I also have some textbook. Please. Coordinators, please. I have some important textbook and some papers. If you have anybody want to continue the research, please refer to me. I'll guide them how to go through this all these things. So this we ended the conclusion. Sorry. So here types we are discussed, and then current trends also. What are the technologies? Current trends in that. So adoptions, modern technologies, EV infrastructures, and battery technology. These are the recent research. See, these are some references I have taken. Thank you. Any queries, please can ask. Welcome for
Hello,
the
madam.
doubts.
Madam,
Yes,
I
sir.
have one doubt, ma'am.
Yes,
How it is?
yes, sir. Please.
Actually, you gave for the information about IC and combination of the EV vehicles, then hybrid
Sir,
vehicles.
your voice is little
Hello,
breaking, sir. Sir, your voice is
hello.
little breaking.
Now it is okay, ma'am.
Yes, sir. Tell me, sir,
Hello.
please.
Madam, actually, you gave the information about IC engine and electrical vehicles, and there is a combination about IC and hybrid vehicles.
Yes, sir.
Now the petrol engine, then they are taking for CNG, madam. They are taking the simple adapter, and they are taking for the converter also. Go for the
Mm-hmm.
petrol and CNG. They are taking, no, ma'am. Is
Yeah,
there
yeah.
any possibility we can go with the IC engine and connect it to with the EV vehicles, ma'am?
Sir, that category only come under hybrid electric vehicle, no, sir. So
Actually, uh,
IC engine with combination of battery only, that only it is
mm,
called the hybrid vehicle. So hybrid vehicle also we have
hybrid vehicle.
two mode of configuration, sir. In that
Yeah,
hybrid
this is
vehicle,
a very clear. Is a clarity go for the IC engine is not a petrol, is not a diesel engine, ma'am.
gasoline, not petrol, sir. Gasoline only majority it is combined with gasoline only. Many practical vehicles now is moving with the gasoline and diesel. So I am not much
But
aware of that petrol combination, sir.
yeah,
I read the paper in the combination of gasoline and electric
electric.
and diesel and electric. I have
Uh,
not read the regarding petrol and the electric vehicle.
uh,
Not seen it, sir.
electric vehicles.
Madam,
Yes, sir. Yes, sir.
gas
Please.
and battery combination will be there, man.
Yes, sir. It is there, sir. It is available. Many even gasoline examples. I forgot the car models names and all. It is
Station
available,
for
sir.
Okay,
you.
sir. Thank you.
Yes, yes. Good evening.
Is there
Thank you, sir. Thank you, sir. Thank you.
Ma'am, I have one query.
Yeah, please.
How much range anxiety problem will be overcome by these electric vehicles?
Rain anxiety, nowhere related, no, sir. Rain anxiety, why you are asking this particular question, sir? Because rain anxiety, you are relating to which part of the thing?
Range anxiety is the
Range anxiety, right? No,
yes,
you are asking about range,
yes,
right?
ma'am.
Actually, that's what, sir. If range anxiety, the fear can be overcome if you are installing more infrastructures, then range anxiety can be reduced, sir. Because charging stations, if I am traveling from Tamil Nadu to Bangalore, so previously we can find only some one or two stations only. That we have to search. Now n number of stations in the petrol bunk itself, the charging station is available now, sir. So if you are seeing, if you are traveling in that highway, you can see wherever that petrol stations is available, no diesel petrol that station is available. There also they have given autonomous stations are have come because in that Indian petrol oil Bharat petrol bunk itself, some autonomous electric chargers they have come. They have installed these things. So we have the app. We have to install the app, particular app. We have to install it, sir. For each autonomous distributors, there's a one specific app is there.
Okay,
So
okay, ma'am.
there, yes, sir. There, if you are go there, then there is an autonomous station, not related to that petrol oil station. So we can only go, we can only charge our vehicles. Then we can that facilities nowadays is available, sir. Available.
Okay, okay, ma'am. Along with the battery capacity, we can also use this regenerative braking, right, ma'am?
So regenerative braking, you are asking in terms of implementation or how actually regenerative braking based on the power rating, sir. If regenerative braking cannot be fully recovered, so in some extent only it is possible. So if you go for the more range, more power range, if you go, then fully recovery is possible. That too,
Yes.
in where we are driving, that's what matters, sir. Where we are driving in
Yes,
cities
yes.
or highways, the
Small
torque.
specifications will be considered in that.
I'm not getting, sir.
Small specifications will consider while adapting this regenerative braking, ma'am. That's why I'm asking.
Okay, sir. Actually, regenerative braking, that recover of regenerative depends upon the vehicle torque also, sir. Vehicle torque, how much even where we are driving, that also part of matters. So based on that, yes, sir, the designing possible itself, they will make
Okay,
it.
okay. Thank you so much.
Thank you, sir. Any,
Is there any participants?
if there any questions, please.
Okay, thank you, ma'am. I express gratitude for
Thank
Dr.
you, sir.
Kodai and all insight and time preparing. We thank you. Thank you for your expertise that
Thank you
has
so
brought to us.
much.
Ma'am,
Thank you
ma'am.
for all the participants that were late night all hear the lectures. So thank you for your patience and thank you for your hearings.
Thank,
Thank you for the organizers to give the opportunities to share my knowledge. Thank you so
thank you
much.
so much,
Thank
ma'am.
you.
Thank you, sir.
Thank you.
Thank
Thank
you.
you, ma'am.
Thank you all.
Thank you, ma'am.
Thank you.
Is
Thank you,
there
madam.
any feedback link, feedback or
Yeah,
certification?
yeah. We'll send you in the WhatsApp group, ma'am.
Okay, okay. Thank you so much.
We'll send in the WhatsApp group. Yeah, if feedback only you will get also. We'll send a WhatsApp within a minute. We'll send you.
Okay.